fellow students and with our professor, we are happy to present a paper, a short paper with our current research directions. It's called Towards Modeling AI-Based User Empowerment for Visual Big Data Analysis. Let's quickly jump to the agenda, what we want to show today in this short presentation. I always have to look at the time. First of all, we want to give a short introduction what we understand with user empowerment for information systems. Want to give a quick introduction about the IVIS for Big Data reference model and how it influences user empowerment. How we derive the AI to VIS for Big Data reference model. Then give a short presentation about our conceptual model in terms of how we can apply AI for empowering users in the context of big data analysis. And after that, I'll give a brief overview of our research roadmap we derived, where we want to dig deeper and where we want to focus on. The topic of user empowerment for information systems is a topic which is definitely there already for several decades. One major work we cite often in our paper and we rely on is from Gerhard Fischer and Mr. Nakakochi from 1992. So it's definitely not a new topic. User empowerment for information system focuses on the relationship or on using the user's intellectual potential as good as possible in order to maximize the usage of the system. So it's kind of a symbiotic relationship. And it's, according to Kim et al., strongly related to psychological aspects, but also to knowledge. So they summarize empowered users in context of information systems need to believe in their own skills and capabilities. They need to understand what interaction capabilities a system provides to them and how important they are. So they should have an internal ranking. And they should know to what degree they can influence the system with their activities. If we look at the IVIS for Big Data reference model and how it's involved with user empowerment, it's a reference model my fellow author, Marco Bornschlegl, introduced in 2026. And it's a reference model for the application domain of visual big data analysis. And it describes how systems that want to, our information systems that want to enable users to explore data and to benefit from big data in any form. It describes how these users can interact with the data, what processing steps are being followed, and what different user stereotypes exist. From very technical user stereotypes, for example, in a data integration, up to management level user stereotypes that consume the highly aggregated results in forms of dashboards. IVIS for Big Data is not only a theoretical reference model, but it's more than that. It's kind of a framework with based on a service-oriented architecture, multiple prototypical implementations, and it has been validated already in several research and industrial projects across multiple domains, for example, in the robotics industry, excuse me, or with OEMs in the automotive industry. And IVIS for Big Data empowers users during the process of visual big data analysis through enabling them to simulate different actions, activities, to give them views on the different intermediate results along their exploration journey. And most important, or very important, it enables the different users to exchange information and knowledge and to benefit from the experience the different users have. And in context of IVIS for Big Data, we realized that we, at multiple points, we use artificial intelligence, but the reference model itself does not cover it. So that's why we wanted to go from this. This is IVIS for Big Data to AI to VIS for Big Data, another reference model, which utilizes the IVIS for Big Data pipeline from left, data integration, to right, insight and effectuation, And it describes, on the one hand, how we can use the process of visual big data analysis to derive and sharpen AI models. And on the other hand, visualized on top with the model deployment, how we can apply AI itself, models, in order to analyze data, in order to automate workflows during this visual big data analysis, or to improve the user interface. And on the latter aspect, the improvement of the user interface is what we focus on with our short paper we're presenting here. For this, we strongly rely on the multifaceted architecture presented by Fisher and Nakakochi, which consists of 3 layers, from the domain knowledge on the bottom to design creation on top. And it describes that the domain knowledge and growing domain knowledge can be used through feedback, the specification, improve the actual construction, and bring both closer together. And if we want to interpret that for the context of visual big data analysis, we propose that the specification might be represented by a mental model of the user, how to conduct a visual big data analysis query or information need. And on the other hand, the construction represents how he actually instantiates that, or how, what activities he actually performs. And on the bottom, we, as introduced in the previous presentation, we think that this works in cycles, and during the cycles, we improve, we learn from inefficient workflows, we use them to improve our mental model, what actions not to take. We learn from successful workflows, but of course, we learn from additional domain knowledge and from building up knowledge and insights about the data itself, which might be domain specific. And that's why we propose, by following this architecture, to look into a 2-step approach where we want to apply AI in step 1, which is on the right side here, to extract insights, potentially relevant insights for the current users from the big data from already. And step 2, communicate this via the user interface to the users in order to inform them, but most importantly, enhance their self-confidence to goal efficiently reach their goal. Translated in a user story, this looks like on the left-hand side, a uncertain, overstrained user. Then in the middle, the AI processes potentially relevant knowledge and communicates this in picture C to the user, which then acts confident with the user interface and knows exactly where he or she wants to dig deeper. And this visualized on the wireframe, or a wireframe of the Ivysobic Data system. This might be potentially then visualized here in the knowledge bar, where formerly the users could exchange their knowledge about certain data artifacts, for example, and this could be accompanied with additional information or insight about certain aspects of the data. And of course, we could also give hints about potential activities they could follow. Looking at the time, I try to roughly go through the research roadmap, which consists of 3 potential topics. In order to validate this conceptual model, we have to identify potentially user-empowering use cases, which, as I said, might be domain-specific. So we follow this 4-step procedure. 1, we want to identify manual activities in visual big data analysis. We want to identify relevant challenges, since we think that these might be use cases where we could help the user utilizing our information system. And then we want to model them in a use case framework and visualize their relationship. We want to look into the topic of explainable AI, since we use results from AI. We want to transport them as trustworthy as possible. And we think explainable AI and the approaches that came up here recently are interesting and could be used for both visualizing and transporting the information. And of course, then we need, with this additional information, we want to validate our conceptual model in a first way, via a active interrogating cognitive walkthrough with sketches of the user interface. So these are our immediate next steps. And with watching the time, and sorry for being 1 minute late. This is our short paper presentation. Thank you very much.